Our first problem is problem 34, and that problem reads, catching a wave, a 77 kilogram surfer starts with a speed of 1.3 meters per second, drops through a height of 1.65 meters, and ends with a speed of 8.2 meters per second. How much non-conservative work was done on the surfer? Okay, well, up till now we've been dealing with conservation of energy, meaning all of our energy is conserved, and that means the change in energy between the initial and final conditions is zero. The energy can be transferred into a different type of energy. For instance, we can convert kinetic into potential and vice versa, but we can't get rid of it. Now we're going to deal with non-conservative work, and what that is some sort of work that's being done on the system or on the object where the energy can't be transferred back in. Friction is a good example. In friction, what happens is you have energy that's converted into heat, thermal energy. Sometimes it makes a sound if you push a counter across or a desk across the floor. It'll sometimes make a squeaking sound. That's another form of non-conservative energy that's being created by friction. Sometimes you get emission of light, particularly with electromagnetic systems. So any system that's creating noise or heat is going to be removing energy from the system, and we call that non-conservative. So in this case, non-conservative work is a result or can be shown to be the change in energy of a system when the energy change is non-zero. So if we actually do have an energy change that's not zero, then there is a non-conservative force acting on the system. So let's look at what our final and initial energies will be. So our initial energy is going to be, well, we're going to have some kinetic energy to begin with. Right? And then we're also going to have some potential energy, because remember the surfer starts near the top and then decreases their height by 1.65 meters. Well, we're just going to assume that the height of where they started is 1.65 meters, and then their final potential energy will be zero because their final spot is 1.65 meters lower. So the final energy will only be kinetic energy. Okay, so if we want to find the change in energy, we take the final, which is 1/2 mv final squared. Then we're going to subtract off the terms from the initial energy. 1/2 mv initial squared minus mgh. Okay, so we've got an m in each of those terms, so I'm going to go ahead and pull that out. Okay, so we've got 77 kilograms for our surfer. It tells us that their final speed is 8.2 meters per second. Okay, minus 1/2. The initial speed was 1.3 meters per second. We're going to square that quantity. Then minus 9.81 meters per second squared times the height, which is 1.65 meters. Okay, so we're going to multiply all that out, and what we get is about 1,300 joules. Now, usually, if something has lost energy, then the value of delta E will be negative. In this case, the surfer gained energy through non-conservative forces, and those non-conservative forces are basically the pushing of the wave. So positive means it's gaining energy, or has gained energy.